This is going to be a discussion of the first step in hypothesis testing, and I'm just going to go to the notes and we're going to highlight the important things in the notes. So let me share this, and we'll start right here. Okay, so in the notes, and by the way, for all of these steps, you should have downloaded and printed out the chapter 8.2 hypothesis test structure notes that are in the content area of the D2L homepage. If you go to the content down to chapter notes, down to chapter 8, you'll see the first one is the hypothesis test structure. So please print that out. You can pause the video at this point and do that if you need to, and then start it over again. So as you recall, last time I started out with the rare event rule for inferential statistics, which states that if under a given assumption, the probability of a particular observed event is extremely small, we conclude that the assumption is probably not correct. The first words in there, under a given assumption. Okay, so step one basically is defining what that assumption is. And we have in step one, we're going to look at three main things. First of all, we want to define the unlikely probability. Recall that when we did determine if something was unlikely, we usually compared that to 0.05, which is a typically used, but it can be another number. It could be 0.01, 0.025, what have you, just a small probability. So alpha is that unlikely probability. It's the Greek letter alpha. Let's zoom in. Can I zoom in here? No, I can't think. That's basically the lowercase Greek a, which is the probability of rejecting the assumed parameter when it is true. Okay, it's called a type 1 error because the assumed parameter can be true and yet still give us unlikely values of the parameter or of the test statistic. So there's a chance, but it's an acceptable risk, a chance of being wrong. But anyway, that alpha is the unlikely probability. The second thing is we have to have a claim. Once we have a claim, we're going to build hypotheses in the third step. But what does that claim say? Claim has a particular structure, and the structure is going to be the parameter is the first thing in the structure of a claim, a relationship that parameter has with a given value, and then the given value. So parameter, relationship, value, and here's an example right here. P, a proportion in a binomial probability, a proportion which is a binomial probability of success, that is a parameter in a binomial population, so to speak. And the example here is that P is less than 0.65. So somebody is claiming that in the population, that proportion is less than 0.65. So you'll see we got the parameter, P, the relationship, less than, and the value, 0.65. So that's the structure of a claim. The three parameters that we're going to be testing in chapter 8 are the proportion, P, proportion of successes, and the second one is mu, MU, the mean of a population, and sigma, the standard deviation of a population. So once we have defined a claim, we're going to construct what are known as hypotheses. And the first one is a null hypothesis, which is designated as this H0, an H with a subscript of 0, and an alternate hypothesis, an H with a subscript of 1. And sometimes you'll see it as A, okay? Capital A or lowercase a. And basically the null hypothesis then, the value, remember they're all going to have this structure right here. It's going to be a parameter, a relationship, and a parameter, relationship, and a given value. In the H0, we're always going to use the same parameter as the claim, the same value from the claim, but the relationship may be different. Same thing with H1. It's going to have the same parameter as the claim. It's going to have the same value of the claim. And it's going to have a different relationship. The null hypothesis, the value that is in that relation or in that hypothesis is the assumed value back up in there in that rare event statement. It's the assumption. Okay, so H0, the null hypothesis, is always going to have the assumed value. And then H1 is parameter, a relationship defines that the parameter may differ from the assumption if the assumption is rejected. All right, so let's go down and find out what the claim might actually look like in terms of the relationship, okay? And how do we find the relationships in H0 and H1? Well, first thing we need to note is that the claim can be one of 6 relationships. It can have one of 6 relationships. The claim, the parameter is greater than some given value. The parameter is less than some given value. And the parameter is not equal to some given value. Or we can have that the claim relationship is that the parameter is equal to some given value, or the parameter is less than or equal to some given value, or the parameter is greater than or equal to some given value. What we want to note here is that these first relationships right here do not have an equals part. It just says greater than. It doesn't say greater than or equal. The word equal does not appear there. Same thing for less than. The word equal does not appear there. Not equal, we see the word equal, but not equal means not equal. Okay, so there is no equal part here. Okay, but the last 3, equal, less than or equal to, or greater than or equal to, have an equals part. Well, when it says equal, that is the equals part right there. When it says less than or equal, that means the or equal means that it can be equal. Okay, and in the greater than or equal to has an equal part because it says it can be greater than or it can be equal. Okay, so those are the 6 possible. 3 of them do not include an equality. 3 of them do include equality. Now, let's talk about H0. The assumed value is going to be in H0. The relationship in H0, you will notice, is always equal. Okay? So notice, though, that when the claim doesn't include the condition of equality, since H0 is equal, it is not the claim by any means. Okay? But when the claim does include the condition of equality, and H0 is always equal, so there's commonality between H0 and the claim. And so we're going to say that when the claim includes the condition of equality, since H0 is equality, we're going to say that it's basically the claim. Okay? You need to remember that. Then let's go to H1. H1 can be less than, greater than, or not equal. It can't be anything but those 3. You'll notice that when the claim does not include the condition of equality, the relationship in H1 is the same as the claim. Greater than in the claim, greater than in H1. Less than in the claim, less than in H1. Not equal in the claim, not equal in H1. So H1 is going to be the claim in all three of those cases, okay? Then if the claim does include the condition of equality, then the relationship in H1 is the complement of the claim. If the claim says equal, then that means the parameter, saying the parameter is equal to a specific value. The complement of that is everything on the number line except that value. So the H1 relationship is not equal. When the claim says less than or equal to, well, what does that include? It includes a particular value for the claim or for the parameter and every number that's smaller than that. What's left on the number line? Everything bigger than that. So greater than is the relationship in H1 in that case. And similarly, when the claim says greater than or equal to, that means that number and anything bigger than, well, what's left on the number line? Anything less than. So H1 is the complement of the claim here. So notice that H1 can be greater than up here or down here. It can be less than down here, or I'm sorry, here and here. And it can be not equal in these two cases. It can only be one of those three things. And because we have only those three things, we're going to be looking for that observed event that has an extremely small probability. We're going to be looking where the extremely small probabilities are, and that's going to be in the tails of the distribution, which you'll see in step 2 and beyond. So if we're looking at an alternate hypothesis of less than, that means we're looking in the right tail. We're looking for an alternate hypothesis that is, I'm sorry, this was greater than. If the alternate hypothesis is greater than, we're looking in the right tail. If the alternate hypothesis is less than, that means we're looking over in the left tail for the extremely small probability observed event. And if it's not equal, we're going to be looking in both tails. Because if it's not equal, that means it's on one side or the other. So we need to consider both tails. Okay, so that you need to remember this, what tails are involved for the possible relationships in H1. So this table has several important parts to it, and you need to become familiar with this. And the more practice you have, the more familiar you're going to become. And so I'll end this video with this. Stop sharing, and we will stop.